So balancing of COVID-19 dataset using GAN. So coronavirus is one of the largest pandemic we face today, and it has no symptoms, and it is impossible to test each and every person by a viral test or using an antibody test. So the simplest way is to analyze the X-ray. But the problem with the X-ray dataset is that the number of images is very low, and it is not balanced. So to address the issue, I'm proposing a solution of producing GAN images using GAN, uh, and putting it in the dataset so that it becomes balanced. So GAN are a powerful class of neural network that are used for unsupervised learning. It consists of a generator and a discriminator. Generator produces the fake images. Discriminator tells whether the image is fake or not. So the COVID-19 attacks the respiratory organs, and it can be analyzed using X-ray images. All hospitals have X-ray imaging, and it is easily accessible. So the problem is that the data set is not balanced, and we need to balance it. And the fake images can be produced using GAN to balance the data set. So the flowchart consists of a generator and a discriminator. The input to the generator is noise, and the discriminator, and the input to the discriminator is the fake images from the generator and the real images from the dataset. And the discriminator tells us whether the image is fake or not. If the image is fake, then the image is backpropagated to the generator. So the input to this is the set of training images and latent dimension. So the first process is training the discriminator. The second is training the generator. Step 3 is combining both the discriminator and generator to produce the GAN model. Step 4 is training the GAN model. Step 5 is repeating the above steps still, and the discriminator cannot say whether the image is fake or not. So the implementation consists of training the generator, the discriminator, and the GAN model. So first the discriminator. Discriminator tells us the image whether the image is fake or not. The discriminator first downsamples, and the image is flattened, and unwanted 40% is dropped out. As the output needed is to say whether the image is fake or not, a sigmoid function is used, and an Adam optimization function is also used. In the generator, the input is A128 28 by 28 latent space images. The images are upsampled 4 times, and it gives a size of 224 by 224. The model uses a hyperbolic tangent activation function in the output layer. Third is combining the discriminator and generator together to produce the GAN model, and the discriminator is not again trained in the GAN model as was trained previously. And in the training process of the GAN model, the images from the generator and from the dataset is given to the discriminator for the training purpose, and it uses an Adam optimizer. The GAN model generates images and is added to the dataset to the COVID dataset. The imbalancing problem is solved using these uh, fake images. The images generated by GAN model exhibit all the relevant features of the dataset. So this is the output after 500 epochs. In this work, generating real-like images from X-ray images of COVID-19 dataset is implemented with the help of GAN. In future, by creating such images and augmenting with the available dataset, an efficient classification algorithm to predict the presence of COVID-19 from X-ray images is possible. With this approach, costs associated with COVID-19 detection can be reduced to great extent because X-ray imaging are very much cheap compared to the present system of COVID-19 detection. Thank you.